All right, welcome to part 3 of the Unit 2B practice test. So we're going to finish up this page. Then we have one more page front and back, and then we should be done. So this will either be the last part or there will be a part 4. We'll find out depending on how long it takes me to film it. All right, so number 13. Identify two pairs of functions from the equation bank provided that represent parallel lines. So we have this little bank provided, and we want to find two pairs of parallel lines. So in order for lines to be parallel, the slopes are the same. So they have the same slope. So fortunately, all of these are written in slope-intercept or point-slope form, so it's really easy to identify the slope here. Okay, so if I want to find two that have the same slope, let's just write to the side what the slope of each one is. So we have y equals 2x plus 1. The slope is 2. Y equals negative 8. Or, I'm sorry, x equals negative 8. What that means is that this is a straight up and down line, so my slope is undefined. And this is a straight up and down line. It's going to go through negative 8 on the x-axis. And so you'll have varying y values, but all of your points will have an x-coordinate of negative 8. Number 3, y equals negative 1. Again, this is just y. There's no x. This is going to be a horizontal line that goes through negative 1 on the x-axis. This has a slope of 0. All right, we have a point slope equation. So right here, there's my slope is in front of the parentheses. So my slope here is negative 2. We have y equals 4. Again, this is a horizontal flat line. Slope of 0. Right here is our slope and point slope form. So this is a slope of negative 1/2. Here's my slope here. This is a slope of positive 1/2. X equals 6 would be a straight up and down line, so the slope is undefined. All right, so I need two equations that have the same slope. So if I look, number 2 and number 8 have the same slope, so I can write those down. Those will be parallel, so 2 and 8. Let's see, so those are both undefined, and then 3 and 5 both have a slope of 0. Excuse me. So those have the same slope, so those would be parallel. I'm looking, I don't see any other lines that have the same slope. All right, so 14 is going to ask us the same thing but for perpendicular. So we're going to have to come back and forth on this one. So perpendicular lines, if two lines are perpendicular, then the slopes are opposite reciprocals, which means if my slope is, let's say, negative 6/5, then the perpendicular slope would be positive 5/6. So one would be negative, one would be positive, and your fraction would flip. All right, so let's find pairs of perpendicular lines. All right. So number 1, we have a slope of 2. Perpendicular, so this is actually positive 2/1. So perpendicular would be negative 1/2. So the slope perpendicular to line 1 would be the slope of line 6. So 1 and 6 are perpendicular. Over here, or let's see if we can find another one. 2, we have an undefined slope. So that's going straight up and down. Perpendicular to that, so undefined means we have something over 0. okay? Perpendicular would mean 0 over something, which would equal out to be 0. So our undefined 2 and 3 would be perpendicular. So 2 and 3 are perpendicular. We actually have plenty of these that are perpendicular. So 2 is undefined. We also have a slope of 0 at 5. So 2 and 5 would be perpendicular. Okay. All right, we did 2 and 3. However, 8 is, ooh, goodness, y'all can't even see that. 3 and 8, we have 0 and undefined. So 3 and 8 would be perpendicular. Okay. All right, so that's it for 3. All right, number 4. We have a slope of -2. The perpendicular slope, since this is -2 over 1, perpendicular would be positive 1 over 2, which is number 7. So 4 and 7. Four and 7 are perpendicular. And I think you get the idea at this point. Let's see, 5 should be perpendicular to 2 and to 8. I think we've already done 2 and 5. So 5 and 8. And I think that's it. But pretty much, if it's perpendicular, the slopes are opposite reciprocals. All right, number 15. Write an equation in slope-intercept form for the line parallel to this that passes through this point. All right, so parallel lines, in order for them to be parallel, the slope has to be the same. So my slope of my parallel line should be -2. And it has to go through the point -4, 7. So I don't have enough information to put it in slope-intercept form, but if I have a point and I have a slope, I can do point-slope form. And then I can convert from point-slope to slope-intercept. So point-slope is y minus y1, which is 7, equals m, which is -2, times x minus x1, which is -4. So -4 becomes +4 in the parentheses. And then if I want it in slope-intercept, we're going to have to do a little bit of maneuvering. So we're going to have to, all right, oops. So the first thing we're going to have to do is we're going to have to distribute this -2. So y minus 7 equals -2x minus 8. And then to get y by itself, we'll have to add 7 to each side. And y is going to equal -2x minus 1. All right. Number 16. Number 16, write an equation in slope-intercept form for the line perpendicular to this one that goes through this point. So we're going to do the exact same thing that we did in 15. The only difference is my slope should change. So remember, parallel lines, perpendicular lines, the slopes are opposite reciprocals. So if my slope here is 2 over 3, perpendicular should be 3 over 2. This slope is positive, so this slope should be negative. And we want it to go through the point, 8, -5. All right, so we have our slope, we have our we have our slope, we have a point. We want it in slope-intercept form, but we don't have the y-intercept, so we're going to do it in point-slope first. So this should be y minus -5, but minus negative becomes positive. So y plus 5 equals negative 3 halves times x minus 8. So we plugged in our slope, we plugged in our point. We're going to distribute the negative 3 halves, and this is y plus 5 equals negative 3 halves x. And then negative 3 times negative 8 is positive 24, divided by 2 is 12. So plus 12. And then to get y by itself, we will subtract 5. Y equals negative 3 halves x. 12 minus 5 is 7. All right, and there we have it in slope-intercept form. All right, number 17, scatter plots and trend lines. So this is, I actually prefer this question on the test to the one on the practice test. Because remember, the real test is mostly multiple choice. So number 17 is a multiple choice question where you'll have which graph and trend line best models this data. So you'll get to pick from 4 instead of having to do your own, because I always stress out over trend lines. And I don't know if it's just because I'm OCD and a perfectionist, but like trend lines bother me. I just don't. They're easy, but you can't do it perfectly, so I don't like it. Okay, so each box, since this is 50 for 2, that means each box is worth 25, which is just good to know. And then, since this is going up 2 for 20, that means one box is worth 10. All right, so we're just going to plot our data first. So we have a point at 90, 20. So 90, this is 75. 90 is going to be about here in the middle, up to 20. All right, then we have a point at 125. So at 125. We have one at 110, 30. 125, 35. So right now this is pretty linear. And then we get to 140. At 40, this should come a little bit closer to the 150. It's kind of starting to curve a little. 155. 53, so here's 50, that would be about here maybe. 170, so this is 175, so it should be a little over here. And 60. 180. And 66. And 275. So overall, it's not perfectly linear, but it does look fairly linear. So I'm going to take a straight edge and do the best I can to kind of get a graph that fits my data. It's not going to be perfect. It's not going to be perfect. But we're going to do that. And that looks pretty decent. Okay, and then B says, use your trend line to determine which is the best prediction for the dosage of medicine for a person who weighs 230 pounds. So this is 225, 230 would be about here. So that would be about here, which looks to be about, what, 87 milligrams maybe? So we made a trend line, we did that. Okay, I don't like this because this isn't very exact. So I'm going to show you how to do this a little more exact. We're actually going to, let me scoot this down. We're going to use Desmos. And I'm going to pull it up on my phone. Since I didn't think about this, I could have done screen capture, but I didn't think about it. So we're going to use Desmos on our phone. which, by the way, you can do this too at home. You can't do this on the test, but you could do this at home. Let's scoot this over and stick this here. Okay, so first thing I'm going to do is, I'm going to make a table. I'm going to type this table into here. So we have 90, 100, 110, 125, 140, 155, 170, 180, and 200. Okay, and then I'm going to come back to my Y's and type in the second row. So that's 20, 25, 30, 35, 40, 53, 60, 66, 75. Okay, now notice you don't see any of these points plotted on the graph above, and that would be because, I didn't mean to go to that. That would be because of my axis. So if I look, my x's go from 90 to 200, or if I look on my graph down here, I go from 50 to from 0 to 275. So, So we're going to go from 0 to 275. My y-axis goes from 0 to 100. Okay. And so now we have the same graph. So mine was not nearly as pretty as this, but this is exact. All right, and then I want a trend line through this. So I'm going to type in y1 and then regressed against, that's that squiggly line, m times x1 plus b. So what that does is that gives me my trend line. So I have y, basically I have y equals mx plus b. So I'm going to write that down here. But instead of m, I have 0.51, we'll round it, 0.51 x minus 26.79. So now I have a trend line or a linear regression. And then it asked what to predict for a person who weighs 230 pounds. So I'm going to come up here, I'm going to click on my trend line and scooch my finger over till I can see Sorry, I posted some quizzes for you guys. They're getting in my way. So go up to 230. And at 230, I have 90.039. So we have 90.039 or 90.4 milligrams. So about 90 milligrams for a person who weighs 230 pounds. So that's more exact than a trend line. And basically what that means is my trend line was not the best. I wasn't off by much, but my trend line was not the best predictor for this. All right, so that puts us at 18 minutes, which means the only thing we have left, I believe, if we go to the back, is your constructed response. I will film a video of me doing this, but what you can do is, I believe this is the same problem as the last video, or the last constructive response. I was thinking I could leave it, but you know what? I might just go ahead and try to knock this out in this video. That way you only have 3 videos. Now I've got to go to the dentist in about 10 minutes, so let's see if I can knock this out before I go to the dentist. All right, so we have Wendy's window washers. They charge an Affordable Care Act tax of $50, and it costs $25 to wash a window. So my function f of x is going to equal What am I paying over and over again? That's my slope, 25. I'm paying that per window, so 25x. What am I guaranteed to pay even if they don't wash any windows? Which I know doesn't really make sense, but before they wash any of my windows, I have to pay that tax. So that's that plus 50. And that's it. When I go to graph this, I have 0, 0 in the corner. This is going to be my number of windows. So we can have this go up by 2s. Each box represents 1 window. So 2, 4, 6, 8, 10. This is the number of windows. And then over here, this is how much I'm paying. So we'll go up by 25s, which means this would be 50, 100, 150, 200, and 250. Okay, and this is the total cost. Okay. So we are going to graph our function now. So I know even before I wash any windows, I have to pay that $50 tax. And then it is $25 per window. So one window should cost me $25 more, so that's at 75. 2 windows will cost me a total of 100. 3 windows will cost me 125, so on and so forth. Should be linear because you have a common difference. You're paying the same thing over and over again. Also, this should be discrete because I'm not going to pay for half of a window to be washed. If I pay for a window, I expect the whole window to be washed. We're not playing the how many portions of a window, like that makes sense. So we have our graph labeled, we have our axes scaled appropriately, they are evenly scaled, our function is linear, and it is discrete. All right, identify the y-intercept. So it crosses the y-axis at 0, 50. Also, if we're looking at our slope-intercept equation, we have our y-intercept is 50. So what does that $50 represent? That is the Affordable Care Act tax. I'm just put ACA for Affordable Care Act tax. All right, identify the slope. So a lot of people are going to be tempted to say up 1 and over 1, which yes, I agree, you are going up 1 square and over 1 square, but remember, each square is worth $25. Also, slope-intercept form. What is my slope? 25. So my slope, ooh, that's ugly, is 25. What does it represent? That is the $25 cost per window. It cost me $25 per window, so that's what my total cost increases by. Okay, so I hope this was super helpful for y'all. I'm going to go ahead and sign off on here. I hope you guys have a great evening. Good luck on your Unit 2B test and study hard. I will talk to you guys later.